Hi, everybody. Thank you very much for joining this webinar. I'm so excited. I hope you can't tell that. And to be talking to you about releasing, about how environments as a service and Bunnyshell helps you increase your release frequency. So in order to get started, let's talk about me. I'm the CTO and founder at Bunnyshell. I put that there, my LinkedIn. So if you want to say hello, I'm more than happy. Marketing also told me to put the news that I was introduced in 30 under 30. And my journey started as a software engineer, as a sysadmin, as a DevOps, as a cloud architect, and then I ended up being a CTO, but I still work on all the other departments. And I'm glad this was my journey because I understand all the challenges and all the pains throughout the engineering team. Now, to end the About Me section, I'm an animal hoarder. I love bunnies. I love dogs. And bunnies are the reason why our Bunnyshell is called Bunnyshell. Because after I had my own bunny, I never imagined my life without a bunny. And I'm sure that after you try Bunnyshell, you're not imagined before you tried it. So this is the agenda. We're going to talk about environments, about engineering challenges, what they are and how they are solved and why they are so difficult to solve, about the concept of environments as a service and how it fits into the development lifecycle. Then I'm going to show you how environment as a service helps you increase the release frequency. And then we'll have the Q&A section. First, we need to establish what an environment is. An environment is the workspace that the developer uses to develop. It's the application of the infrastructure of the production, or it's the workspace of a QA that starts testing. So basically, in all the cases, it's the application, the database, the infrastructure, but also the tests that are applied to ensure that the environment is valid and the access policies that are required to ensure security. So an environment is a multi-layer that can be replicated for all the development team. So what are the use cases? So for developers, they need development environments. They can't work anymore on local environments because they have very many services, and they also need cloud native dependencies. So they can't look locally. They need a remote development. Now QA, bugs in our case, in order to test what Python has developed, our dev, needs a preview staging environment. He needs to have an environment as soon as Python made a pull request in order to test and give Python some feedback. Now, Lisa, on the other hand, she needs environments as soon she needs to run parallel tests on environments as soon as the developer does pull requests. The DevOps needs to see that all those environments don't drift from production, that they are up to date from the application and the infrastructure point of view. Now the product, on the other hand, he needs to do user acceptance testing and also demo, like in demo sprints in which he shows the features to the stakeholders. Now the sales, the most important department in every business, needs environments for demos. He needs to have environments that he can prepare for his prospects and needs them to be up and running the moment he needs to have the call. So environments, it's not just for developers, but it's all for everybody in a business, for all the engineering teams and also the sales. Now, we'll have a poll question that, and we're going to ask you, what are the main challenges in releasing more frequently? Okay, I'll continue, right?
Yes, you can continue.
Perfect. So should I also answer? Oh, I can't. Okay, I can't vote. Good. Good. So let's go into engineering challenges. So there are three main engineering challenges that engineers face in all businesses. It's the developer productivity, it's the release frequency, and the development cost reduction. In development productivity, you need to have on-demand environments for all developers so they can start working on code and not to manage environments. Those environments need to be managed so they are production-like and not to drift from application and configuration. For release frequency, which is our main subject now, we need on-demand environments for QA, for product, so for all the departments that are involved in giving feedback to developer. And also we need to shorten the feedback loop. It should be a very short time in which after a developer creates the pull request, the QA, the product is prepared to give feedback. And then removing bottlenecks with shared environments. This is one of the issues that create defects in development pipelines. When you use environments with shared resources and those resources are not shared in a smart way, and says that, okay, we can use the same services, but we need different databases, for example, in a RDS, then you create bugs, you start having merge conflicts, you start breaking up someone else's environment, and that's not productive, and that does decrease the release frequency. Now, the cost optimization, on the other hand, is important because if you try, as you see in the presentation, to solve some of the issues when developers work a lot in environments, you try to solve them with DevOps, then your cost is not going to disappear. It's just going to shift. You're not going to spend as much, developers are not going to spend much time on managing environments. They're going to be more productive, but your cost is going to shift on the DevOps side. And retaining DevOps is an issue, and hiring DevOps that have similar opinions of how they should implement a certain pipeline is pretty difficult. So we reduce cost optimization by providing on-demand environments to developers, by removing the time spent by developers on managing those environments, and by creating ephemeral environments. And I'll tell you what ephemeral environments mean for all the QA and all the product. Now we'll discuss in depth some of these issues here, some of these challenges that affect release frequency the most. First, the on-demand environments. Why is it difficult? Why is it difficult for each and every developer, each and every QA and automatic pipeline to have its own environment? Basically, it's because applications are complex. It's not 2 or 3 containers, and not just containers, tens of containers that you deploy. It's linked with infrastructure. It might be a hybrid application, both deployed on a Kubernetes, but you might have also a function as a service or a Lambda service that you are running that are part of your application architecture. So releasing is not just a simple deployment. You have to interact with all kinds of providers that you work. Then the workflow means not all resources can be created instantly. They have to be created in a certain order, and it's more related even to data. The seeding of data has to be done prior to the applications to be deployed. And then after you deploy the application, if developers change the structure of the database, they have to run the migrations. And then if you don't want to have different data, if you don't want to have different schemas, you have to keep all the development environments up to date. But in the same time, QA and automatic pipelines might need different data sets in order to test. So these are some of the challenges that makes on-demand environments quite difficult. And we haven't tackled infrastructure. Most of applications now are created cloud native, which means that they are made in mind with using cloud services. They are created that they scale on based on cloud resources. So cloud native services are introduced into the application logic, which means if you try to reproduce a local environment, you will have to mock some of the services. You will have to self-manage some of the services, not have a managed database as a service, but run your own MySQL or Postgres, and then you start having different environments, which is not production-like. So This is why on-demand development environments is challenging, and this is why environment as a service, as you see, is a solution which takes care of all these points. Now, production-like environments means that all the development environments respect the same structure as the production one. Even if the production environment is highly available, it contains lots of resources, and each and every resource is not a bottleneck and it's highly available. That's not a requirement for development and for staging, but the requirement is that they use the same services, they respect the same network structure and the same security policies. Even if you deploy all the services in the same time and the same, like on a local instance, if you don't use the cloud native services, you are not going to have a production-like environment. And the reason that is important is because if you don't have that, then you'll end up with having the classical problem, it works on my computer. Because if you are testing against a managed database, for example, and not with a cloud database, they don't behave similarly. There are queries that can behave in different ways because they are configured in different ways, and it's very hard to maintain local configuration with remote configuration as they are not handled from the same GitOps repository. So why is it hard? Well, maintaining security policies, on the other hand, is difficult when you want to create development environments. They need to respect the same policies. And you need, for example, to have some services to be private, but in the same time, developers need to access some of the services. So even if you respect some of the network structure of the production environment, you need to enable developers to debug the applications. Then shared cloud native resources. As you saw in the architecture before, some of the cloud native services are shared, but in the way that RDS servers can be shared, but each and every environment has its own database. This is more complex to provision, but in the same time, it keeps your infrastructure, it maintains your infrastructure sanity. Then with the data pipeline, to be production-like, it means from the automatic tests point of view that you have a good database data, and it's not correct to get it from production. But you do need to have certain pipelines that take the data from production and remove the sensitive data in order for developers, for QA and automation tests to have a seed which they can use to do correct tests and do correct automatic tests. So moving forward, and this is one of the hardest challenge. And let's say that now every developer has an environment and it is production-like, and it is production-like now, but applications change and infrastructure change. Applications change versions, and those versions need to be updated on all environments. And also database structure changes. So migrations need to be updated on all development environments whenever there are changes. Also, from the infrastructure points of view, there are also some manual changes that are applied, and we need to find the drift between what was in the GitOps configuration and what is in the cloud, and we need to ensure that all environments are the same, which means that we need to implement GitOps both for the application and for the infrastructure. Because if we don't do that, let's say that you're not updating all the application versions, then developers are going to work on environments that are not similar to production. They are developing features on an older version, which may cause defects to appear in the development pipeline, which will just get the ticket back to them to redevelop it, and the overall release is just going to take longer. productivity in development is also affected because of the frustration of it. Because if you are a developer, you love to code. This is what you do. And if your time is spent on environments, on updating them, and every day you go to work and the first thing that you need to do is not to develop, but see if there were other changes and to manually apply the changes, you are going to get frustrated. And then your productivity is gonna decrease, and then the release cycle is gonna decrease because you don't work as good. So moving forward to the feedback loop. The feedback loop is the loop in which automation tests and QA give feedback to developers on their change. It's important that this feedback loop is as short as possible. So basically, whenever a developer does a pull request, it's important that right away there is a new ephemeral environment, a temporary one, that is available to the QA that has to test, or the automation pipeline that has to test. So the developer receives the feedback loop as soon as possible. This is a simplification of the process, but think of it as this. The developer does a pull request with a new change. Then the CI/CD sees the new change and creates through Bunnyshell an ephemeral environment that is dedicated to an automation test. If the automation test fails, then the pull request is closed and feedback is sent to the developer. If the automation test succeeds, that this ephemeral environment is removed and another one is opened for the QA if they have if the team has a UI a manual QA that needs to look at the interface, so the QA can look as well. If the QA finds that doesn't find any defects, then it can the ephemeral environment can also pass to the product, so he can give the feedback as soon as possible. And I think the product is pretty underestimated in release cycles, because product people are less technical, so it's very hard for them to create environments, as they don't have any knowledge either of Git or the CI/CD systems that might solve this problem in-house. For them, it's challenging because they have to do share screens with developers. Well, with ephemeral environments, they'll have their own dedicated one, and which they can test that everything that the developer does is correct. So why is it difficult? Why is it difficult to shorten this feedback loop? Because you need regression testing on every change. It needs to be, whenever a developer creates a pull request, to test that nothing is broken, you need end-to-end testing on every pull request, because if you have an environment and it is production-like, you don't need to limit yourself to only comparing the certain service that was changed and the very related services. You can do a full testing. If you do full testing with end-to-end testing at every pull request, this will just make defects to appear sooner when the developer is still developing on that certain task and not later. So he has another feature to develop on and he has to come back. So it's better that the defects are discovered as soon as possible. And also manual QA ephemeral environments that need to be created and need to be served for the QA, because again, just like the product QA are more technical, of course, but they don't work necessarily with Git and IDEs. They need a nice way of accessing the endpoints of the application. Sometimes they work a lot with task managers, such as Jira, or they see the pull requests. So you need to serve them the endpoints of those environments so they can access them. Then there is cost reduction. So cost reduction is always a problem. I haven't heard. I have no issues with cost. And even if anyone said that, I wouldn't believe him, because okay, we have the on-demand environments. Everybody is using resources. Everybody is using separate ones. So what about the cost? Because okay, the application doesn't cost a lot, but what about the cloud native services? Managed databases do cost a lot. So what's the solution here? Well, First, there's the availability rules. Developers work just 8 hours a day. They don't work 24 hours a day, I hope. So you might as well close those environments whenever you finish working on them. So on top of the management, the drift management and the provisioning of the environment, you also need an availability rule mechanism that says when the environment should be up and running and when it should be removed. Also, in this procedure, you need to maintain some of the static data, such as volumes, such as the endpoints with which the environment needs to be accessed, so that the developer, when he comes the next day, he has his environment just like he left it. Imagine coming the other day and his environment is up, but his data disappeared and all his changes to the database disappeared. This is not ideal. It is safe cost saving from the resources point of view, but not for the developer's time point of view. Then there is ephemeral environments. So in order to shorten the feedback loop, we've introduced ephemeral environments created at pull request. Well, also they are deleted whenever pull requests are closed. Ephemeral environments are like single purpose environments. They are created so that QA and product and other developers, if they want to do some code review and also need to see the changes, to give the feedback to the developer. As soon as they are removed, the pull requests are removed, the ephemeral environments are closed. And another thing is infrastructure. Infrastructure is expensive. So of course you need, in order to remove it, like a database, the managed databases don't have a stop-start funccionality. It would be nice if they had, but they don't really have that one. So you really need to implement a pipeline in which they create backups of the data that is written, so that and then it is removed, and then the next day when developers come, the database is restored with the latest versions. Going further, there is the DevOps. So we have these challenges here that cause productivity to decrease and causes our release frequency to be not that great. So who should be solving this? And the answer is that DevOps people should be solving this. But the DevOps priority comes in this order. They do production and they work a bit more on production, and their fifth priority is still the production, and one of not coffee. I was not sure about the order there is development environments. Sometimes development environments are the developers are passed to developers, and the reality is that they don't always have the know-how how to fix them and how to implement how to fix the drifting. But in the same time, it's not their responsibility. So what do we do here? Well, we hire more DevOps. So we split. This team will handle production, and this team will handle only development environments. But that's just shifting costs. On the other side, the DevOps, as I said, it's not as easy to retain, and DevOps people work in very different ways. They come with different experiences, and sometimes pipelines tend to become a bit like monsters. Nobody knows what's there, and if a main DevOps leaves, it might it's very difficult to maintain it and to change it, and they have to switch to another pipeline, and it's not causing anybody any good. So right now we will post the second poll question. Where are in your cloud native journey? And I can't vote on this either. No. Okay. Let's just put it there. So going into environment as a service, right now we've talked about challenges, we've talked about problems, and it's time to talk about the environment as a service. Environment as a service is where your application, your infrastructure, and tests, because the tests are part of your application, undergo version control. Whenever you modify one or the other, all development environment and all environments created by the service are also updated. Its main value is to solve the three challenges in engineering teams: the release frequency, the development productivity, and the cost reduction challenge. So what does it look like? Is it a new tool? Is it a new, how will engineers interact with it? Well, environment as a service will not, is working with all the tools that developers already know. So it works with Git, because mostly developers work with Git and their IDEs. So developers will not have to learn a new thing. It will just integrate with their natural flow. It is integratable with all the other services, such as testing, such as CI/CDs, because it has full API. And also, you interact with environment as a service with CLI. Developers love to work with CLI, DevOps love to work with CLI, and they like to create environments and shut down environments and modify the branch they're working using the CLI. On the other hand, QAs and product love using UI interfaces. So it's not just a tool that has to be set up again, has to make QA and developers learn something new and with a big learning curve, so that they can't focus on coding anymore. They have to learn a tool that will later on help them. A development flow with environment as a service looks like this. So a developer will create a pull request. A new ephemeral environment will be created. On that ephemeral environment, all the automatic tests will be run. And if the tests are successful, then it will go further to the manual QA testing. If they're not successful, it's going to give feedback to the developer. With the manual QA testing, after it finishes, it gives the feedback to the developer. And if the changes, if it didn't find any defect, then the feature goes into it is merged into the production. What happens behind of the scene is the following. When the new development environment is created, somebody needs to deploy the application, to deploy the infrastructure, but you have multiple colleagues, so other application components will be also updated. So somebody needs to update them and also maintain to run the database migrations on the other hand. Now, when the ephemeral environments are created, somebody needs to rebuild the new images with the new feature. It needs to push to the registry. It needs to see that the builds are as fast as possible. And also detect, if you have monorepos, what changes, where was the change, where the change happened, in what specific folder, so we don't build all the repository, right? So on the other hand, if the infrastructure is in GitOps and a DevOps changes something, it ensures a more, it adds another security policy. All the environments need to be auto-updated. So somebody also needs to take care of the GitOps, right? And that's the environment as a service. For developer, it's just creating a pull request and creating another environment for the QA. But all the processes behind of it need to be solved, so that it just doesn't solve the on-demand environments, but also the cost optimization and the drift management. Perfect. I think I just spent the perfect amount of time now. So now it's the time to see the environment as a service in action, and I'll walk you through the Bunnyshell platform that helps engineers to release at the speed of warp, at the warp speed, and we'll see an application that you will see a pull request that creates ephemeral environment that can be used for testing and that are easily clonable. So each and every developer has its own environment. Perfect. So going to the presentation, the first thing is that Bunnyshell can be integrated with all Kubernetes clusters from all cloud providers and all Git integrations from all Git providers. And of course, it can be integrated with all types of CI/CD, whatever you're using, GitHub Actions, GitLab CI/CD, everything, because Bunnyshell has a full API that can be used. So the second thing is that I already created an application here that has many microservices, an authenticator, a backend, a frontend, a vault, and a worker. So there are some microservices here, and they also have some infrastructure, some cloud native resources on AWS. If we want to ensure that there is an increase in release frequency, we want to ensure that we can have on-demand environments. So how would a developer have its own environment? Well, it's as easy as cloning. You can use the UI to clone an environment, just like, let's see, Shani's environment. Perfect. And there's a new environment that is ready to be deployed for Shani in order to start developing. So this is the UI, and of course, the CI/CD would work like it would work the same way. It would clone a new environment so it can run other tests. Also in the CLI, the developers can go into their Git repository, and there they can do a commit. So a new environment is spinned for them. So in this environment, I've worked on a feature, right? And this feature, I created a pull request into the main branch, and it created an ephemeral environment. Well, that's good and dandy. And in that ephemeral environment, what I did is that I modified the front end. Let's see here. And I also added a new column in my database schema. So after I merge this pull request, all the other environments need to be up to date. So all the other environments need to apply this, this command. So this is a way in which drift management is obtained. For example, if I go and I, let's see here, if I go and I accept this pull request, merge pull request, confirm merge. Perfect. What's going to happen is that as soon as the pull request is merged, the ephemeral environment will be removed, and all the other development environments will be redeployed. So in the sense with the migration, if a developer creates a new update in the interface, like he did now, so the and a migration, it will be deployed to all the environments. Perfect. So now if another developer comes and he wants to create another, merge another feature, he will also create a pull request. So in GitHub, if I go and I create a new pull request, and I say that I also want feature 2 to go into the main branch, perfect. And I create a pull request for it. Perfect. What's going to happen? Let's see. Did I create a pull request? Yes, I did. What's going to happen is that Bunnyshell is gonna create a new ephemeral environment for this. So on-demand environments are created as simply as cloning any environment. Of course, each environment has its GitOps file that can be used and can be added into the Git repository. And whenever you change anything here, it's also going to update all the environments in the interface, right? For all the development and all the QA people. Whenever you do an update to the application, it's going to rebuild the image and it's going to deploy it. But that also is available for the Terraform side. So Bunnyshell is fully integrated and does full Terraform GitOps. So whenever anyone needs to update any Terraform resource, they are automatically updated to all the other development environments. For example, if you want to add another resource, such as, what am I missing here? let's say that we want to separate some logs and I want a separate S3 bucket. I can go in the env YAML and I can add another bucket there. So all the environments will have the new bucket. So this will shortly allow all developers to have each and every one a development environment for themselves, and also to ensure that QA have their own environments to test, shortening the feedback loop and ensuring that we have a good release frequency. So I've finished faster than 10 minutes, which was the proposed time, but that's not a bad idea because it was moving pretty fast. So this was the presentation, and thank you very much. And then right now we're gonna skip into the, I still need to share my screen. We need to skip into the QA section. Perfect.
So Roxana, thank you for the presentation. That was great. We have our first question. Is the Bunnyshell pipeline capable of environment rollbacks?
Yes. So, and if you want to do a rollback, you can just, for example, whenever you roll back a change, for example, in Git, you can roll back the change. It will be automatically rolled back into the environment. Also, you can roll back by specifying the SHA that you wanna, the particular SHA that you wanna deploy.
One other question I'm getting is, can you please elaborate more on the Terraform and how that exactly works in the Bunnyshell environment? Some more details around that.
Okay, sure. So the Terraform, you can connect any repository containing the Terraform modules in Bunnyshell, and then you can attach them to different environments. Whenever you attach them, they are deployed and maintained for that certain environment. You can, when you attach the Terraform modules, you can override some of the inputs that you need to use. You can set some configurable variables only for the developer to change, so that developers don't mess around with hundreds of variables. They may change only certain ones. For example, if you have an RDS instances, you might want the developer to have some limited access on what instance size they want to add for that specific RDS. And you can do that by creating a configurable variable. Later on, when the Terraform is applied, you have some output that you can map to the applications that run in the environment. And of course, GitOps applies whenever new resources are added in Terraform or existing resources are updated. Bunnyshell will redeploy them and will manage all the development environments so they are up to date.
And another question from Farkas: how does Bunnyshell help with local environments?
With local environments, so Bunnyshell comes as you can have a local environment that has all the services, but at a certain time you will you want to have all the cloud native services as well. So Bunnyshell allows you to have a hybrid environment. You can have some of the services running remotely and just some of the services running locally. Of course, you can do full remote development in which you change only the services remotely. And if you want to do local development, you can develop only some of the components locally and just push the changes on the remote development.
One more question around Kubernetes.
Yes.
Can you please elaborate around where is exactly Kubernetes deployed? Is it like your own cloud environment? Is it our cloud environment? Just a little more explanation on that.
Yeah, so it's your cloud environment. So Bunnyshell integrates with Kubernetes clusters deployed on your cloud environment, and we support connecting Kubernetes cluster on AWS, on Azure, on Google Cloud Platform, and on DigitalOcean. So if you have a Kubernetes cluster, you can, on those clouds, you can connect them in Bunnyshell, and Bunnyshell will deploy and build your application on your Kubernetes cluster.
All right, so we have one more. Can you explain a bit more how Bunnyshell and GitLab CI interact with each other?
as Bunnyshell has a full API, GitLab CI/CDs such as GitLab CI/CD can interact with Bunnyshell by creating environments. For example, if you want your automatic tests to run each on his own environment, the CI/CD can trigger an environment creation, right? Not only Bunnyshell will do that on every pull request, but let's say you want to create nightly regression tests. It can trigger Bunnyshell to create environments, so it can run the tests on it, and after that to receive the feedback. This is one of the way that they would interact. Sure. So, and my experience and the biggest thing that was creating delays in the release frequency, like this was the biggest one, it was drifting. So even if you start the first step is always to do the on-demand environments, and start to pre-provision the environments and number them and say, we use stage 1, stage 2, stage 3. So the first step is to do the on-demand environment, and it starts working great, then to use the environments that had shared resources. But the second step, and when it comes to drift, and not only application drift, but I think the worst is the database drift. When you start having schema, and it's very difficult to solve, because some of you don't know how to apply some of the changes or where they come from, and the environments suddenly become broken. So this is the second thing that needs to be solved. And when they do, they start running some kind of cruns sometimes to solve the data, or they start the day always with a new seeding from the production database, and always working on a new seed, so that they remain with the correct schema. Then the costs start to appear, because you need to handle all the databases with the data, and you have to recreate them each and every day. So this is the last part that appears. So the three challenges: the productivity, the release frequency, and the cost reduction, happen in this order, and they become more and more difficult to solve, because at the end, when you've reached and increased the productivity a bit, you start having the cost, but you can't go back to the way it was. So you need to find another solution that works for you and solves all three of the challenges.
Got it. Thank you about that. We have two more questions. The first one is, can I migrate my monolith to Kubernetes easily?
Well, it depends, and with a bit of dedication to Dockerize the applications, you might encounter some difficulty in Dockerizing the application, but if you spend time with it, the benefits later will be huge, both for the perspective of performance, because it's very easy to scale with Kubernetes. It adds multiple layers that you can use, and you can scale each component separately from all the application. And also by the cost optimization, because you're not using full VMs for your application, and whenever you scale, you need to add more virtual machines. You scale just based on the resources that each component has to use. So it's better. It's not very easy, and it does depend on the application, but the advantages will come very soon whenever your team decides to do that.
Got it. Thank you. The second question is, how do you make sure you don't keep environments running when they are not needed?
So for the ephemeral environments that are created on a pull request, they are closed as soon as the pull request is closed. And also you could have a time to live that is closing the environments whenever they are opened for too much time. Also for development environments, that there are the availability rules that can be used in order to close them at night when developers aren't working, and then start them during the day. This is available for the application in Kubernetes, and you might also want to do that for some infrastructure resources.
Got it. Thank you. All right. And one last question. If I have more questions, how can I reach to you?
Well, can you answer that?
Definitely. So you can email us, and if you want to get in touch with Roxana, definitely you can look it up on LinkedIn or roxana@bunnyshell.com. You can send all the technical questions and they will get answered. And one other question which came up into chat was, do you have a trial account in order to test the application? So yes, you can go to bunnyshell.com and you can get started free.
Okay.
All right. So thanks everyone for your time today. And we will follow up with the recording of this webinar and some more resources. So please look out for that. If you have any questions, as I said, you can send it to roxana@bunnyshell.com. You can start your free trial. You can utilize Bunnyshell free. Just go to bunnyshell.com and you can get started free. So thank you again for your time, and today's webinar, we are going to end it. Thank you.
Thank you very much. Thank you for joining.